Warm greetings, my dear students. Welcome to Physics Clinic at the Red Rose Academy. Today's topic is we are going to learn about indefinite integrals. Okay. So before that, you must know what is derivative and what is antiderivative. Okay. So what is derivative? Derivative is what is changing, that is derivative. Okay, so and how fast it is changing, so all these things it represents derivative. Okay, then what is antiderivative? Antiderivative is what original function can produce this rate of change. Okay, so first of all, my students should be very clarified in concepts. So what is derivative? Derivative is how fast and which is changing, what is changing. And antiderivative is what is the original function, that original function, which original function or what original function could have produced this rate of change. So that is antiderivative. Okay, so you know that derivative is a function tells us it's instantaneous rate of change. Everything we've learned, right? How can you say like this, f prime of a? uh, that is equal to instantaneous change. H tends to 0, plus or 0 minus, whatever it might be. You can take this as the first principle, like a slope, right? So this is instantaneous rate of change, or geometrically, it is the slope of the tangent, we can say. If there is one graph, then it might be the slope of the tangent. We saw that, right? Suppose if you draw a graph like this, okay, then it will be the um, I mean the curve. So for this curve, this particular thing is a slope. Okay, I can say it is the slope of the tangent to this particular curve, this one, f prime of a. Okay, and this and all we have learned already. And suppose, for example, I can say f of x is some x cube. What is f prime of x? You know the methods, 3x square, right? So the derivative of x cube is 3x square. Clear? Okay. So what is an antiderivative? So we need to find the function, right? So antiderivative is a function. Okay, antiderivative of a function also we can say. It is a function whose derivative is f of x. Like, for example, f of x, okay, you are taking 3x square, this as a function. What is the antiderivative? So which function is responsible for this? That is antiderivative. Plus some error also we need to take. That error is that error is nothing but what is this? The slope. The slope determines that error. Okay. Plus C is the correction. Okay. Correction in it. If it is 0 plus or 0 minus, there must be, if h tends to 0, 0 plus and 0 minus, there must be a small error. Okay, so that should be corrected by this correction factor. You know, if you differentiate d by dx of antiderivative, okay, that is x cube plus c, it will give you 3x square. So the c is any arbitrary constant. Okay, wow. Because the derivative of any constant is 0, we are not including this. So only x cube is differentiated, that will be 3x square. Okay. So what is the logical connection between uh, the derivative and antiderivative? Okay. So derivative means we saw the rate of change of function. What is the rate of change of function? What function has this as its derivative? That is very important. Okay. So that is antiderivative. So integration is nothing but it is the process of finding an antiderivative. That is an integration. I told you already, if you differentiate the function, very, very small function, if you differentiate that, you know, you have to take a whole curve and differentiate based on this. I taught you already. Okay, so small change in y-axis by small change in x-axis, right? Y1, Y2. And if you do like this, then so many differentiable elements are there, quantities are there. If you want to sum up all these things, that is the integration. So addition of all the differentiable quantities or the integration we know. Okay. Once again. Okay. So right now we must understand what is the derivative, and this is the major confusion between the, among the students. Okay. What is derivative? Let me repeat. What is the rate of change of this function? So that is derivative. Okay. And what is antiderivative? It is the which function is, okay, so we can say which function is derivative into this. That means has this as its derivative. So which function, what function is responsible for this? Then integration is the process of finding an antiderivative. So it includes a lot of methods. We are going to deal with the methods, okay, in later exercises and later problems. First of all, you must understand, remember this for your board exam, JE mains, etc. Differentiation breaks a function, okay, function down into its rate of change. So that is differentiation. Okay. And integration reconstructs a function from its rate of change. Is it clear for you? Addition, total. Reconstructs a function, we can say. It breaks a function, differentiation, integration reconstructs a function from its rate of change. That is very important. So, as a whole, differentiation and indefinite integration, okay, or reversible or inverse process. Okay, say for example, we saw here, okay, x cube, if you differentiate, it becomes 3x square. 3x square, if you integrate, it becomes x cube plus c. So we can say differentiate is the forward process, derivative. Derivative is the forward process, it is the backward. Integration is the antiderivative. Okay, it is a forward process. Antiderivative, if you take antiderivative, it is the reverse process. Can you able to understand? I think you have to understand this one, and derivatives and antiderivatives are given. Another name for antiderivative is integrals. You have to take a note. So you can see all these steps here. Right now you can able to understand what is derivative and antiderivative. Okay, we are going to see the indefinite integrals. What is the geometric interpretation of indefinite integrals? It is given. So what I told you, so x cube plus c, like that I gave. So it is x square plus c. It is defined here. You can understand what is the parabola I drew like here, and explain you it is the slope of the tangent, right? Take a note of all these things. It's very simple and easy. Like this, see, if you consider a curve, this will be the slope of the tangent. See? Okay. So that is the integral. Some properties of integrals also you must learn. These are all the properties of integrals. If there are function like this, you can write this is derivative, means which one is antiderivative, everything you know. And addition, subtraction is also possible here. It's very simple. Okay. And if it is multiplied by any scalar, the scalar can be taken outside. So infinite number of functions also can be added and individually different integrated. Okay, so here it is given in your book. You're asked to find the antiderivative for each of the following using the method of inspection. See here, cos 2x means, you know, what is the whose derivative is cos 2x? Sin 2x is 2 into cos 2x, right? So you can take sin cos 2x as 1 by 2 sin 2x. So that is the antiderivative. Like this, you must find out. Okay. So can you do all these things? It's very simple only. We'll move on to the topic. Okay, so you can able to find out the antiderivative very easily. Okay, so based on this, I told you what is the comparison between differentiation and integration. The first exercise talks about fully. Now we'll get into the methods of integration. Okay, so we'll see methods of integration right now. Okay, I'll explain you. So you must know all the um, formulae which is given in your book. Okay, so here, lot of methods of integration are discussed with. Okay, va? So the methods of those functions which were readily obtainable from the derivatives of some functions. Okay, so on the search of a function whose derivative, so on the search of a function f whose derivative is small f, which led us to the integral of f. Okay, that we know. So, and also as a result, we have to develop new methods or approaches for figuring out the integrals by putting them into standard forms. So, some of the methods are integration by substitution. Okay, there are a lot of methods. So integration using partial fractions, integration by parts. Okay, so we are now going to see integration by substitution. Here we discussed that. Okay, so the given integral, for example, f of x into dx can be transformed, or we can say it is integration by transformation also, substitution or transformation. So integration can be transformed. This is integral, it is known as, okay, into another form by changing the independent variable x to t, substituting actually f of or x as g of t, some function in t. That means if you are considering the integral I is equal to f of x into dx, okay, putting x is equal to g of t here, so that dx by dt equal to g prime of t, right? Okay, so dx is equal to g prime of t into dt. So you are going to substitute here in the place of f of x, you are going to substitute f of g of t, and dx can be written as g prime of t into dt. Okay, this change of variable formula is one of the important tools, okay, available in the name of integration by substitution or by transformation. Okay, it is often used to guess, okay, what will be the useful substitution. That is very important. You have to guess. You should use your creativity. Okay, so and also, usually we make a substitution for a function whose derivative also occurs in the integrand. So these are all the things you must notify. It's very important. We'll discuss with some important problems which is discussed in your exercises. I mean, important, or I can say it is a bit tough for you. That kind of problem we'll do. For example, question number 3 we'll do. Okay, what is question number 3? In exercise 7.1 is you have to identify which is the integrand, I mean, which is the antiderivative. So exercise 7.2, third question in your NCERT book, 1 by x plus x log x. Okay, so it is the question. So you have to put, what is that? X plus log x, it is given, right? So you have to write x plus log x as t. Okay, what is t now? X plus log x. Okay, if you differentiate x, what it will be coming? Okay, so so this is the transformation, right? Let x is equal to, sorry, t is equal to x plus log x. What is dt? 1 plus log x will be 1 by x into dx. Clear? So 1 plus 1 by x into dx, that is equal to dt. So you have to represent all these functions like that. Okay. And then after that, substitute in it what is for dt and okay. So what is for dt? Dt is okay dx by x. Okay, here x plus log x. So what we can do, I will explain you again. So we can take x as common, 1 by 1 divided by x commonly we can take log x, right? This is the integral you have to find out in the indefinite integral. In this, you can take this alone as t. Let t is equal to substitute. Then dt is equal to 1 by x dx. Right? Clearly, it's visible. You can substitute in this. So dx by x can be substituted as dt, and 1 plus log x can be substituted as t. What is dt by t? You have to look into the table, integral table. It is log t. Okay, plus c. So what is t? Again, you have to resubstitute 1 plus log x plus c. Clear? So this is how you have to do. Okay, so like the same, we'll work out for another problem. So another tough problem, I will explain you that. Another one is fifth one that you can able to do. Sin ax plus b, cos ax plus b. Okay, so that is very easy. You can take sine. So fifth one, sine of ax plus b into cos of ax plus b. Clearer? So in this, if you multiply and divide it by 2, it will become sine 2a. So sine 2 of ax plus b by 2. Make sure these two are same angle. That is the main point. And then make this 2 of ax plus b as t. So that is the substitution. In this area only you have to use your creativity. Okay. T is equal to 2 times ax plus b. Okay. What is dt? dt is equal to 2a. Right? 2a into dx. This one. Okay. 2b will be 0. So 2a into dx we can take. So if you simply differentiate sine 2 of ax plus b by 2 into dx, right? So dx can be written as dt by 2a, right? So what is dt by 2a? And you have to represent this as, okay, 1 by 2 sine t. This is taken as t. Dx can be written as 2a by t. Sorry, dt by 2. dt by 2a, right? So it will be 1 by 4a. And sine t becomes minus cos t. Okay. Then again you have to replace. What is t? T is equal to 2 times ax plus b. Is it clear for you? This is the answer. Plus c. Clear? So this is how you have to find out. I mean, this is the method, okay, you have to form. And which sum we can see. And if you take, you can use your identity, you can use your creativity, and also all the basic formula you must learn. And exponential will do one. Exponential is e power tan inverse of x. It's also simple, 18th one dx. Okay. So in this you can put, this is a kind of trigonometrical thing. This is, you can put t is equal to tan inverse of x. And what is dt? 1 by x, 1 plus x square into dx. So same way you have to follow the formulas, okay, fundamental formula. Keep in your mind. So the integral becomes e power t dx by 1 by x square will be dt. So what is that? E power t, if you differentiate, e power t plus c only. So e power tan inverse of x plus c. That is the answer for this. Likewise, you have to follow. Then we'll see 34th and 36 I'll teach you. Okay, 34th and 36. Can we see that? 34th question and 36th question. Okay. What does the 34th question says? I is equal to root of tan x divided by sin x cos x into dx. That is the integral. 34th question. Okay. Let the integral be, okay, root of tan x by sin x cos x into dx. So what we can do? So here it's very tough to identify which can be substituted here and all. It's really tough, but you must have a practice. Okay, you must be very thorough in trigonometrical identities too. Trigonometrical identities as well as the formula which is given in your book for the integration also. Both are very important. So for this, I'll give you some tip. Here you can multiply cos x and here also multiply cos x. I mean multiply and divide cos x. Okay. Then what it will be? How it will be? Hmm? Here if you bring this cos x to the downside, then here also you'll be getting root of tan x into dx by this is also tan x into cos square x, right? It's very simple. You can able to understand why I'm doing all these things. You must be aware of all the formula. Okay, tan x differentiated with secant square x. Secant square x the antiderivative of tan x, like that. So tan and secant are connected. You must know the connections. Then only you will get an idea. Why I have multiplied this cos x and divided this cos x means multiply and divide cos x will give you secant x. So tan and secant is, it is the derivative and antiderivative. So if you put like this, see here, root of tan x and 1 tan x gets cancelled. So root of tan x in the denominator and 1 by cos square x will be secant square x. Secant square x dx, root of tan x. Right up. Okay. If you take t as, let t is equal to tan x. Okay, what is dt? Secant square x dx. So it can be written as dt by root t. Clear? No? So root t can be written as t power half. So don't simply put it as log of 1 root t. It is not like that. Okay, the function dt by t will be log t. But dt by root t will not be log t. So you have to write t power minus 1 by 2 dt. Okay, root of t can be written as t power 1 by 2. That is t power minus 1 by 2 into dt. Or it will be like, what is the formula? Okay, for the integration basic formula, x power n plus 1 by n plus 1 plus c. Okay, here it is t power minus of plus 1 means plus of. Okay, plus c. Clear? What is this? 2 can be brought to the up, then it will be root t plus c. So the answer is 2. What is t? Tan x, 2 root tan x plus c. So this is the answer. Can you able to understand? This is how you have to connect. You must know the connection. Simply, you must know the connections or else it will be a tough for you. Okay. Then I told you to solve this 36th question. What is that 36th question? It shows up the integral will be x plus 1, right? X plus 1, x plus log x, the whole square by x. So you can take, okay, x plus log x, the whole square it is given. So you can write like this, x plus 1 by x. You have to use. So right now, students, you must imagine what I can put for this, what I can transform this into. Okay. So I can transform this like, okay, and then do separate 1 plus 1 by x in this is another thing and x plus log x whole square. Okay, and we can take this x plus log x is t. That is a hint. Because if you differentiate x plus log x, you will be getting 1 plus 1 by x. That's what I'm taking. Let t is equal to. This is how there are so many logical keys and solutions are hidden in the problem itself. So you must try to find that, okay, connections, and which is the key answer, which is the key thing involved in it, which is the key thing hidden in it. Okay, that is your creativity. So integration seems to be very tough because so many students are failed in finding all these connections, okay, and the hidden things. But my students, you must find out all the hidden things and the what are all the connections between, okay. So x plus log x and dt is equal to 1 plus 1 by x into dx. So this is the thing, okay. So into dx, you can substitute t square into dx, right? Dt. The whole, it can be represented as dt. X plus log x can be represented as t. So t square into dt. After that, it's very simple for you. So tq plus 3. That's it. If you find the connection and logical thing and the hidden things, then it is very, very easy to perform the completion. Okay. So t cube is nothing but, what is t? X plus log x, the whole cube by 3 plus c. Can you able to understand? This is what simply we can able to say. Likewise, you have to find out very easy only. So my students, my dear students, you have to find out all the connections. Okay, simply I can say. Then you have to do all these steps. Then we'll see some problems from R.D. Sharma book also.